Hello everyone, welcome to the final and the 12th weekly live session for the NPTEL course of Remote Sensing Principles and Applications. This is brought to you by NPTEL and the SWAM Initiative. I'm Abhishek Chakraborty, a PhD student under the Prime Minister's Research Fellowship Scheme from the Interdisciplinary Center for Water Research at IISc Bangalore, and this course is being tutored by Professor Ishwar Rajshekharan from the Department of Civil Engineering at IIT Bombay. So the same list of four information which I always give. Uh, the video recordings of the session will be made available to you on the YouTube channel, as I've been already sharing with you. The files relevant to the sessions will be made available through a Google Drive folder. The files and the video recordings will be made immediately available after the class. And if the images are taken from the internet, they are solely for study purpose. We don't intend to plagiarize any content. So far, I've already uploaded the list of 11 weekly live sessions videos on the YouTube channel. I usually upload that immediately after the session ends, and this is the link which contains the not only the YouTube videos web link as well as uh, the PDF files containing the weekly live illustrations. Anyways, today's is going to be just a revision class. We are just going to discuss what is the most important one for your which might be the most important questions for your upcoming exam. So I would just go through. I mean, I'm already done with solving all the questions till week number 12. So we will just go back and we will check what all we learned and what might be the most important part. That's it. So in the weekly live session one, we discussed about the kind of remote sensing it is. There's a basic difference between active and passive remote sensing. Active remote sensing, in active remote sensing, the actual sensor also emits its own source of radiation, and it then detects the radiation which is reflected back from the Earth's surface. The passive, on the other hand, detects something which is not actually emitted by it. So, in most of the cases, most of the remote sensing satellites are passive ones, as they detect the radiation coming back from the Earth because of the sun. However, there are a few active remote sensing sensors also, like the ones which deal with the microwave remote sensing. So we discussed that. Then, which of these is not an example of remote sensing? Yeah, we discussed a few questions first of all. But for today's session, I would be dealing with only the mathematical parts. Yeah, so the most important formula in the first few lectures of this live session are: number one, the Planck's law, from which all the resulting laws like the Stephen Boltzmann law, Wien's displacement law are actually derived. So you need to be well versed with them. And I also discussed how the Stephen Boltzmann law the Wien's displacement law comes from the Planck's law itself, uh, as well as the Stephen Boltzmann law. So Planck's law is the most fundamental law in the initial parts of this course. Then we learned a bit about the polarizations, how different kinds of polarizations affect the sensing, remote sensing. Uh, we also discussed how and when the two waves would be coherent. We learned a bit about the Doppler effect. Some detailed numerical questions would be actually discussed in the later weekly live sessions related to it. Uh, Anyways, I mean, whenever the source and the observer are not stationary, if they are moving, then the Doppler effect will happen. Okay, so that is the most important part. The frequencies and the wavelengths, they will vary, and that is what it deals with. So that was the part related to the first weekly live session. Let me note it down, the most important parts. Okay, so we learned about the fundamental laws like uh, Planck's law, Stephen Boltzmann law. You should be by hurting them. And the Wien's displacement law. We also, of course, learned about the Doppler effect. Doppler effect when either the source or detector is moving. So Doppler effect actually alters frequency f and lambda. That is the most important part. So let's now move to the second weekly live session, whatever we discussed there. Yeah, so here we started learning a bit about the radiometry and radiometry primarily. So we learned how absorption, scattering, they will vary. What is path reflectance? What is downwelling radiance? So we learned that. We also learned about scattering, transmission through atmosphere. So it was, yeah. So this is what we learned about some new terms like transmittance, absorptance, and reflectance for the very first time in this course. Then we started a bit about the radiometric concepts also. We started with some isotropic point sources, and then we moved into the Lambertian geometry. We solved a few questions. So this is the part which is very important. The second weekly live session would deal with. From here, radiometry starts. So concepts of radiometry. Then what is absorption and what is scattering? That is also what we learned. We also learned that scattering is in fact there are Rayleigh scattering, non-selective scattering, and Mie scattering, and they depend on the sizes of the either the wavelength or the particle. And usually we also learned a very interesting thing that usually in uncorrected remote sensing images, the blue band image usually is the brightest because the scattering is the most in the blue band as the wavelength is less. The scattering, you remember, at lower wavelengths, at such wavelengths is directly proportional to 1 to power lambda 1 by lambda to power 4. So lower the wavelength, more would be the magnitude of the scattering. So that is what we learned. We learned radiometry for the very first time. Then we learned about what path radians are. What is absorptance, transmittance, and reflectance. So transmittance can only happen in non-opaque bodies. The body should be partially or completely transparent. So it would allow the radiation to transmit through it. Absorptance is the absorbed energy by the initial energy. The transmittance is the transmitted energy by the initial energy. Reflectance is the reflected energy by the radiation by the initial incident radiation. So that is what we learned in this weekly live session. Let's move further. What about weekly live session 3? Let's check that out also. Okay, so we again did a few things about enhancing our knowledge about the reflectance. We for the first time understood what are the basic spectral reflectance curves. The reflectance of, let us say, water would be vastly different from that of a healthy green vegetation or soil or snow. And there are of course absorption bands due to which there are dips in the reflectance spectrum. We learned a bit about the vegetation indices also in this part. However, in detail, it would be covered in the later part. Bandwidth. Okay, so this was primarily about the resolutions, how the resolutions would vary. So this is what this part of the weekly live session was all about. So you learnt about the four fundamental resolutions. So the four fundamental resolutions are the spatial resolution, temporal, spectral, and radiometric. So spatial resolution is the fundamental size. I mean the least fundamental size which you can detect. That is what a spatial resolution is. So temporal resolution is the revisit time. Spectral resolution is how easily you can distinguish between the spectral features. So more the number of bands, easier. I mean, and narrower the bandwidths are, the easier would be your capability to distinguish the features, surface features. And radiometric resolution is the amount of brightness in it. So if let us say the radiometric resolution is 8-bit, so it would have 2 to the power 8 brightness levels. That is 256 brightness levels, and so on. I mean, if there are n-bit resolution, then that would mean 2 to power n uh, brightness levels, and you record it in a sensor. In case you're recording it in an unsigned format, then it would be from 0 to 2 to power n minus 1 brightness levels, quantization levels, in case it's an n-bit sensor, a radiometric resolution sensor. Okay, so we are done with this part also. This was the weekly live session 3. Let's finish. Let's see what we discussed in weekly live session 4. So we again discussed about the different radiometric resolution, the color values, the same thing which I was discussing. Then we discussed about the ways the data is stored in a sensor, whether it's band interleaved by line, band interleaved by pixel, which is BIP. We took a few very elaborate examples to understand it, or whether it is band sequential BSQ format. We also understood how they are actually stored. So that was what we learned here. Then for the first time we learned about the radiance calibration and everything, how to convert the DN value uh, and everything, and this would be very interesting. Okay, how is a DN converting into, let us say, radians? This is what we understood. The quantization levels we understood. Uh, how to convert the DNs, that is also what we took here for the very first time in this course. So it consisted of the formats, consisted of the data formats, band interleaved by line, band interleaved by pixel, and band sequential. Okay, so that was what we understood. Then we moved into conversion of DN to radians. How do we do that? So there is a calibration strategy for that. We understood how that is actually done. So this is what was the second part of this lecture. Now let's move to something else. Now let's move to the weekly live session 5. Okay, so we understood about the reflectance features, and again the vegetation indices was actually covered in details in this part. vegetation indices and reflectance features. That is what we actually understood in this part. So let me write it down. Vegetation indices and spectral reflectance features. That is what we learned in this part. Let's move to live session number 6. Today's would be a very short session actually. We have already finished all our numerical examples, so it would not take a lot of time. I would just discuss what are the most important things which we discussed. Okay, again means law started, so it's nothing new. We discussed it earlier also. Total radiance existence is again which we learned. So this part actually had questions from the Planck's law also. You need to memorize this in fact, because it would come consistently in several questions. Then a bit about radiometry. Again radiometry. We learned about the inverse coil law. That's it. This was what we actually understood. Okay, the questions were very general, by the way. We learned a bit about questions related to emissivity in this part, and a question related to the swath viewing angle and everything was discussed. So very simple, more or less. Swath and viewing angle. The questions are based on simple trigonometry, by the way. What did we discuss in weekly live session 7? Yeah, again, we learned about something which approximates the Planck's law, known as the Rayleigh-Jeans law. Okay, so the Rayleigh-Jeans law is what we discussed about. It is only valid at large wavelengths, and that is low frequencies. Rayleigh-Jeans law is what we covered in this part. We also understood about how it is derived and the two forms of it. I mean, one form is the frequency form, one form is the wavelength form, and they may look very different, but they are actually similar. That is also what we discussed. Then we learned about the brightness temperature for the very first time, by the way. Very important thermal infrared concept. So this kind of question will certainly come. I can guarantee you that. So please be prepared with it. Black body. Okay. So for the first time, questions on brightness temperature was covered. Brightness temperature and an approximation, that is Rayleigh-Jeans law, was also just illustrated in this weekly live session. Then let's check what we discussed after this. So far we are done with weekly live session 7. Let's move to the session 8. Okay, in session number 8 we discussed about okay, now we proceeded into the microwave part. SLAR system, side looking aperture, that is what we actually discussed. We solved a few questions about them, radar and everything. Radar, eco. That I mean, we started with radar remote sensing from here. We also did a bit about the Doppler frequency related to radar, which I actually explained in the very first weekly live session also. So radar concepts actually started here. Radar, and this is also a very important formula. If you have to by heart it, I'm sure something will come out of this. So concepts of radar is the one which we discussed here, and so from this part, radar microwave, remote sensing, they started. Let's see what did we discuss apart from that. In weekly live session, yeah. So we learned a bit about how the satellites operate. That is very important. The fundamental law is, of course, the Newton's law of gravity, which would exist between any two bodies having a particular amount of mass. Uh, Centrifugal force and gravity force, they actually determine the orbital speed, orbital velocity, orbital period. So that is, I mean, that is what we started discussing from this part, and I'm sure something will come out of, of this part also. Orbital speed and orbital period. This is what we discussed here. Sorry, orbital speed and orbital period. That is what we discussed for the very first time here. Next one comes the weekly live session 10. Again, we continued our, how are the satellites placed. We continued our analysis on that. Uh, how they vary with respect to the ascending and descending passes. So it was still a discussion about geostationary satellites primarily, uh, and it would be very interesting. Then a bit about radar also. That is how we ended this part. And last but not the least was the 11th weekly live session. In it, we discussed about the different classification schemes, uh, what kind of LULC would be there. Again, a bit about the vegetation indices. We discussed how the latent heat flux is actually the proxy for evapotranspiration, and a bit about fundamentals. That is what we ended with. So that's it. I think. We learned a lot through this course. I would like to end it here itself because uh, I would just say that you can just go through the weekly live session illustrations once again. Most of the numericals which I've covered, they they seem to be quite strong contenders to come in the exam also. So just try to polish them up, and it would be very good if you try to memorize the formula related to the microwave remote sensing and the Planck's formula. That is essential for you. That's it. I think we should call it a day. Thank you. Thanks for the patience of, being there for the entire 12 weekly live session series for this NPTEL course. Thanks a lot. I would just stop recording now.